Hi, in this video we'll be solving equations using logarithms. So when we have an equation like, let's say, x plus 2 equals x minus 5 or something like that, we can take, if we'd like, the square root of both sides, we can take the square of both sides. Whatever suits our needs, we can do on both sides. So taking the logs is no different. So if you have an equation like, let's say, 3 to the power of x equals 20, then you can just take the logarithms of both sides. So log 3 to the power of x equals log 20. And then you can apply the laws of logarithms, in which I'll be using the power law. So it's going to be like x times log 3 equals log 20. Now remember, these expressions are numbers, right? So what I can do is I can now divide both sides by log 3, because at the end of the day the idea is to isolate x so that we can write the value here, which will be 2.727. Right? There is another way of doing that. If you like, you can take a log of both sides, but this time you can just assign the base to be the same as this number here. Right? If you take the log in base 3 of 3 to the power of x, it must be the same log base 3 of 20, right? The idea behind this is that you can write this as x times log 3 in base 3, so it's going to be log in base 3 of 20. Then just because this is 1, you can directly write down the value, which is 2.727, by just calculating log 20 in base 3, right? So either you just take the log of both sides, which means the base is 10, right? And then you can just divide both sides and end up with the x value, or you can use this number as the base, whatever that is, all right? And then you can just end up with the logarithmic expression that will give you the answer to x. So this is your choice. Both methods work. Another example. Solve this equation and give your answers correct to three significant figures. So we would be very naive to think that quadratic equations won't be involved in this. This actually is a quadratic equation. All you need to see here is that if you consider a being 5 to the power of x, then taking the square of both sides, you will end up with 5 to the power of 2x, right? So this will be a squared minus this will be a, so it's 12a here, plus 20 equals 0. So to solve this, you need two numbers and so on, and the answer will be, so we have a equals 10 and a equals 2 now, and let me make some space for myself. Right, we have to come back to 5 to the power of x. So what we're going to do now is to write 5 to the power of x equals 10, and then I can take the log of both sides. Now if I take the log of both sides in base 5, I'm going to end up with this, right? So basically this will immediately give me x, because I know that this is 1. So it's going to be x times 1, which is x, and log in base 5 of 10 is 1.43, and the same thing I'm going to do for a equals 2. So it's going to be now first of all I have to write down the equation. 5 to the power of x equals 2. So log in base 5 of 5 to the power of x is log in base 5 of 2. This means, just because it's 1, x equals 0.431. So I end up with two x values. So in this example, we are to solve 3 to the power of x equals 2 to the power of x plus 1. Now, here we can't just choose any base. If I choose base 3, it's going to be a problem with this part. If I choose base 2, then it's going to be a problem with this part. So I'm going to go with base 10. So I go like log 3 to the x equals log 2 to the power of x plus 1. And then I will just use the power rule to write x times log 3 equals x plus 1 times log 2. Then on the right hand side I can write x log 2 plus log 2. I can just expand the brackets. And then I will be collecting the terms with x on one side. So it's going to be x log 3 minus x log 2 equals log 2, right? Then you have x brackets log 3 minus log 2 equals log 2. And now you divide both sides by log 3 minus log 2 to end up with the x expression. At this point, I prefer to write this again, but you can just write down the decimal value, which would be 1.7095 up to 4 decimal places. So this sort of equations need a little bit manipulation. You have to play with it a little bit, but before you have to take the logs of both sides. As you can see, you have to be quite familiar with the laws of logarithms and the special cases so that you will swiftly solve the equations without any hesitation. Alright, so make sure that you know them all, and then it's not going to be much of a problem solving such equations for you. Thanks for watching.